The line of best fit is the mathematically determined through very complicated calculations, the best trend line for a particular set of data. So in this video, we're going to show what that line of best fit looks like and what it attempts to do to be the quote unquote best line that we could possibly draw. Now, one thing to point out, if we were to draw our own trend line, it is likely that we would get very close, depending on the correlation of the data, it is likely that we would get very close to the line of best fit. But remember what the goal of this is. The goal of this is to create a line that you can use to make predictions. And if you're creating a line to use to make predictions, you want that line to be as perfect as it possibly can be. So let's take a look at what the line of best fit will look like. This is the data set that we looked at in the previous video for trend lines, where we had along the x-axis, we had the number of years since 1984, and on the y-axis, we had the percentage of households that owned a computer. We see the positive relationship, the same positive relationship that we saw before. We gave a rough sketch of a trend line that kind of went between the different points. It was above these 3 points that are in the middle and below the 2 points that were at the end. But the trend line, our best guess of the trend line, not necessarily as accurate as we can get it. The line of best fit, on the other hand, will solve that problem for us. Desmos has a really neat trick for typing and using lines of best fit. When you create a table in Desmos, the table columns are not automatically labeled as X1 and Y1. When you want to create the line of best fit, you use those same column headers and the approximation symbol to join together X and Y in what looks like slope-intercept form. For the purposes of line of best fit, it's important that you use A and B. For nothing else is that it'll be consistent with what you see on the calculator, but it is just standing in for A is the slope and B is the intercept. Now, if you look at the slope, and I purposely haven't put the line up yet, if you look at the slope and the intercept that we have down here, so here's A as predicted by Desmos, and here's B as predicted by Desmos. These are going to be our slope and our intercept of our line of best fit. You'll see that I did not get a negative slope. You might remember from the last time we did it, when we drew it and did it by hand, I ended up with a negative slope. That means I was probably pretty far off from where I needed to be, that those 2 points weren't really great choices regardless of how I drew it. You'll also see the correlation coefficient right here, which is R. That's covered in another video. I encourage you to watch that so you can familiarize yourself with R a little bit. And so it's time to bring up the line of best fit. So let's see what it looks like. This line of best fit is called the line of best fit because it is the best approximation that technology or human hand can come up with. The reason that it's considered to be the best approximation is that this linear function right here, with the slope of 2.96 and an intercept of 2.37, here's my intercept down here, there's my 2.37. This line is considered to be the best estimate because it minimizes the error as much as possible. So what are they talking about when we say minimize the error? What it's looking at is these distances right here. It's looking at how far away each one of those points is from the line. It's looking at those spaces right there. And it is attempting to minimize those distances as much as possible. Those distances are called the residuals. And if you were interested in seeing them graphed on the x-axis, you're welcome to press the plot button and take a look when you access this file yourself. But these distances for this line are as small as they possibly can get. Those 6 distances are as minimized as possible. If I was to tilt this line even just the littlest bit, they would go off. They wouldn't be as small as they are right now. So the line of best fit is all about minimizing the error. It's not about just drawing a line that goes near all of the points. Like we saw in the trend line video, we could do that ourselves. The line of best fit, as constructed through these calculated behind the scenes calculations is attempting to minimize all of those distances as much as possible. It's trying to fit the line in between those 6 points as best as it can. Now, one of the things you'll see when you do this is you will run into outliers, and outliers will have a significant impact on how these lines are drawn, the residuals, the R, everything's going to change a considerable amount whenever an outlier is involved. So let's take a look at that. Let's imagine for just a moment that we go up to 25 years, which would be 2009. It's the same example that we used previously. We got an approximation of about 81.8. We would imagine that if we would use our rule here, we would get something similar. We could scroll this out. We could zoom out just a little bit. We could go out to 25, and we get an approximation that's 76. It's not near where we were in the trendline video, but it's close enough. We get the right idea. Our trendline in the video before was a little bit steeper, so it makes sense that our approximation was a little bit higher. But let's say, for example, that something happened to all of the world computers, and at 2009, the world was only left with 10 computers. 10% of households had a computer, for whatever reason. You'll notice that now, because of this point that's way down here, this added in point, we get significant changes in the slope and the intercept, significant change in the R, and again, I encourage you to watch that video if you're not sure what R means. And we get a much less steep graph. This line is trying to chase that point because it's attempting to minimize all of the residuals, not just the one at the end, or not just the ones that are really close together. So if something catastrophic happened and the world's computers were all destroyed and only 10% of households had a computer, this line would say, oh, I need to chase that data point as well. So it comes down here. And now we have all of these residuals that are significantly larger than they were previously, all because of that one point. And our expectation is that if we were to add more points that were in that vein, maybe after 30 years we're down here, and 35 years, the line would continue to chase those because it wants to make sure that it's including all of the points in the analysis. We can't just ignore one point from the data set. Adjustments will come in those calculated behind the scenes work that happens to move that line closer to each one of those outliers. So the moral of the story when it comes to a line of best fit, one is you understand that this is a calculation that is happening to minimize those residuals. It's attempting to limit those differences as much as possible. And two, you understand that it's not perfect. There's no way for that line to get through all 6 of those points. In fact, it doesn't go through any of them. But it gets as close as it can. And it minimizes those errors as much as possible based off of the data that you have.